For over a century, batteries have followed the same rule.
Liquid inside. Energy stored. Risk accepted.
But inside this factory, that rule is being broken.
Engineers here are building batteries without liquid.
This isn't a lab experiment. This is manufacturing.
This factory is not making ordinary batteries.
It's building the next generation of energy storage. It's building the next generation of energy storage.
Here, chemistry meets manufacturing.
What's built here could change how the world stores energy. Every solid-state battery begins with carefully controlled raw materials. These powders will replace liquid electrolytes entirely.
Even small contamination can compromise performance.
Each batch begins with exact measurements. Nothing moves forward without verification. At this scale, purity defines performance.
Raw materials are refined to precise particle sizes.
Raw materials are refined to precise particle sizes. Uniformity at this stage determines final performance. Multiple materials are blended into a single electrolyte composition. Temperature control stabilizes the chemistry before shaping begins.
Every batch is sampled and verified.
Chemical composition is confirmed before fabrication continues. Only verified materials move forward. The solid electrolyte begins as a carefully formed sheet.
Thickness here is measured in microns.
Thickness here is measured in microns.
Heat transforms powder into a solid conductor. Handling requires extreme care. Handling requires extreme care. Microscopic structure defines ionic movement.
Uniform thickness is critical for performance.
Electrodes store and release energy during operation.
The anode defines how energy flows into the battery. Moisture control is essential for solid-state cells.
Thickness and density are tightly controlled. Even minor defects can affect performance.
Each layer must align perfectly during assembly.
Now, the battery begins to take shape.
Assembly begins with precise layer stacking.
Assembly begins with precise layer stacking. Alignment tolerances are measured in microns.
Alignment tolerances are measured in microns.
Pressure ensures intimate contact between layers. Solid-state cells can be built in multiple formats. Different chemistries balance cost, performance, and availability.
Now, each cell must be sealed and protected.
Each cell is placed inside a protective enclosure. Placement accuracy protects internal layers.
Placement accuracy protects internal layers.
Every seal is inspected for integrity. Internal structure is verified without opening the cell.
Leak testing confirms long-term reliability.
Every cell is tracked from start to finish. Before use, every battery must be activated. The first charge is slow and tightly controlled. The first charge is slow and tightly controlled.
This process stabilizes the internal chemistry.
This process stabilizes the internal chemistry. Each curve confirms proper behavior. Some cells undergo additional conditioning cycles. Only stable cells move on.
Safety testing begins with thermal stability. Cells are exposed to mechanical forces that they'll face in the real world.
Structural integrity is tested under controlled force. Electrical faults are simulated safely and deliberately. Electrical faults are simulated safely and deliberately.
Containment is designed into the system.
Only cells that pass every test move forward. Individual cells are combined into functional modules.
Electrical paths are established between cells.
The battery's intelligence is added here. Each module is tested before becoming part of a larger system.
Each module is tested before becoming part of a larger system.
Modules combine to form complete battery packs. Cells become systems capable of powering the world.
Once approved, battery packs are prepared for deployment.
Once approved, battery packs are prepared for deployment. They also support large-scale energy storage.
Solid electrolytes enable faster charging under controlled conditions.
These batteries are designed to power electric vehicles.
Different designs optimize different priorities.
Different designs optimize different priorities.
Development continues beyond the factory floor.
Modern energy is built through coordination at scale. Modern energy is built through coordination at scale.
These systems quietly power everyday life. This is how the next generation of energy is made.